Hello, this is Mr. Keaton here to talk to you about video 1.2.3, and today we're going to talk about exponential models. We like exponential models, especially if you can relate it to your bank account or your investments. Anyways, exponential models have a tendency to take off. They have an asymptote down here, usually at x equal y equal to 0. Y equal to 0. Sometimes it'll get shifted up and stuff like that, but that'll come later. Right now, most of the exponential models are going to have an asymptote at y equal to 0. So it hovers down here around 0, it gets really close to 0, and then it takes off, and that's called exponential growth. A few things about b has to be greater than 0. If it's not greater than 0, you get exponential decay. It gets smaller and smaller, and so if b is less than 0, instead it's going to do this, it'll be decay. But we're coming to that later anyways. So b cannot equal 1, otherwise it's not growing, because when we have a times b to the x power, if this is 1, it's not growing at all. It's our multiplier. B is known as our multiplier. If b is just multiplying by 1 over and over and over, nothing changes. You have to put just a horizontal line at y equal to a. Notice a cannot equal 0, because anything times 0 is going to be 0, so that would cause a problem too. So those are little stipulations in there. X is our variable and will be up in the exponent. And all that's saying is we're going to have repeated multiplication. So in this example, they have 3 is our coefficient up front, and we have a multiplier of 2, And so we're going to stick other numbers in for x, like 1, 2, 3, 4, 5. So we'll have 3 when we stick 1 in, it'll be 2. When we stick a 2 in here, that means multiply by 2 twice. So we keep multiplying by 2 over and over. And this would be 3 times 2 to the 5th power right now. So that'd be 3, 4, 5. And here we go, 2, 4, 8, 16, 32, 96. So it'd be 96 down here. So as you can see, we just keep multiplying by 2 over and over. Now, it makes a very significant part here is this concept of this number here in front, our a value, and that is our y-intercept. Our y-intercept is the a value, because 2 to the 0th power is equal to 1, or anything b to the 0th power is always equal to 1. So that means 3 times 1 gives us 3, gives us this point here. So I always start by looking, okay, what's my coefficient up front? 3. That will be my y-intercept. And now I'm going to just multiply by 2. So I go over 1, multiply by 2 once, gives me that point there. And I multiply by 2 again. So at 2, I come up and I go all the way to 12 because I doubled the height. So I can just keep multiplying by 2 over and over and over. And that's the concept of exponential functions. And as you can see, when I multiply this by 2, so the 4th time, I'm going to go way up here to 24. And it's growing really fast. Here it only increased by 3, here it increased by 6, increased by 12. It's just taking off. So that we like exponential growth in some situations. Can work against you if it's in some situations, but often exponential growth is awesome. So sliding on down here, we have another example. Suppose the value of a rare stamp has increased exponentially. So you've got some stamp that's rare and it's increasing exponentially. It was worth $14 2 years after Sean purchased it, and after 5 years it was worth $112. How can you model the value of this? So I have 2 points there. I have 2, 14. This is comparing time and dollar values. And the other point I have is 5, 112. So we can use that by writing our equation. We don't know anything about this except it's exponential growth because they told us. So we have 2 points that we can stick in for x and y, because this is our x and our y values. So I can go ahead and drop 2 in for x and 14 in for y. So that's what they did right here. And because we have 2 unknowns, our a and b here, those are unknowns, we don't know those, we need a second equation. And so what we do is we simply take the 5, 112, and we write our second equation here. And now we're going to go ahead and solve a system of equations. So to do that, why did they stick a 2 in there? I wouldn't have done that yet. They're solving That's because they did this first. This was their number one step. So they solved both of them for A. This is slightly different than I would have done it. Solved both of them for A and said the A's are equal, so we can set those equal. So they set those equal, then they cross multiplied. 14b to the fifth is equal to 112b squared. Divide both sides by b squared. That cancels there, giving us b to the third. So divide by 14, and now we have b to the third is equal to 112. Now we can take the cube root of both sides, and that gives us the cube root of 8, which is 2. So that's where they got that value of 2. Now they can take that and substitute into one of the equations. So they put it in for b, and that gives them 14 equals 4a. Divide by 4 gives them a is equal to 14 over 4. Gives a is equal to 3.5, and now you can write your equation. Y is equal to 3.5 times 2 to the x power. That gives us the exponential function. Took a bit of work. It requires a system of equations to solve that. So you have two unknowns, two variables, substitute them in. It takes a little bit of practice. Anyways, you have a wonderful evening, and there's no problem for you to do on this one.